So given the mass of the substance, you know how to figure out the number of moles. You have to divide the given mass with the relative mass of the particle in grams. And once you get the number of moles, you have to multiply it with Avogadro's number to get the number of particles. So you know how to calculate the number of moles and the number of particles given the mass of the substance. Then you can do the reverse also, right? That is, given the number of particles, you can figure out the number of moles and the mass of the substance, provided you know what that substance is. Let us understand that with the help of this example. What mass of ethane should one take to have so many molecules of ethane? And you should know that ethane is C2H6. That is its molecular formula, and its molecular weight is 30.0. I think you can figure that out. So if you take an Avogadro's number of ethane molecules, that means you have 1 mole of ethane, right? 1 mole of any substance has an Avogadro's number of particles. Here we are talking about ethane that is composed of molecules. I just flipped it. That is, if you take an Avogadro's number of molecules, that means you have 1 mole of that substance. But here we have 6.0 into 10 to the power of 21 molecules. Then how many moles are there in it? Number of moles is denoted by small n. So small n is equal to, multiply these two and divide the product with n. So it would be 6.0 times 10 to the power of 21 over capital N. The approximate value of Avogadro's number is 6.022 into 10 to the power of 23. To make our simplification easier, let us ignore these two digits. So let us take its value as 6.0 into 10 to the power of 23. So it would be 6.0 times 10 to the power of 21 over this. So this is the number of moles. Now how do you get the mass of the substance given the number of moles? If you divide the mass with the relative mass in grams, you would get the number of moles. So to get the mass given the number of moles, you have to divide the number of moles with the relative mass, right? Whatever is there in the denominator here. So relative mass of the particle in grams. So number of moles is 6.0 times 10 to the power of 21 over 6.0 times 10 to the power of 23, and the relative mass of ethane molecule is 30.0, expressed in grams is 30.0 grams. I let you do the simplification. So if you divide the number of particles given with Avogadro's number, obviously you would get the number of moles. You don't have to memorize all these formulae. What do we have next? What would be the mass in kilograms of an Avogadro's number of protons given the mass of the proton in AMU or U? See, if you have an Avogadro's number of any kind of particles, that means you have 1 mole of that substance. So indirectly we are asked to find out the mass of 1 mole of protons. How do you find this out? You know the atomic weight of sodium is 23.0, that is its relative atomic mass. Then what is 1 mole of sodium? 23.0 grams, right? You have to express its relative atomic mass in grams. Similarly, the atomic weight of calcium is 40.0, then 1 mole of calcium is 40.0 grams, its relative atomic mass in grams. So to find out the mass of 1 mole of protons, we have to express the relative mass of the proton in grams. So to answer this question, you need to know the relative mass of the proton. But we are given the mass of the proton, not its relative mass. It is given as 1.007 U. Then can you figure out the relative mass of the proton? It is just this number part, right? Without this unit, 1.007. We have done many examples like this before. Remember, the relative atomic mass of sodium is 23.0, then the mass of one sodium atom is 23.0 U. We simply added the unit U to its relative mass. Here we are doing the reverse. We have the mass of the proton in U. To get the relative mass, we have to remove this unit, just this number. So this is the relative mass of the proton. And if you express the relative mass of the proton in grams, you would get the mass of 1 mole of protons. But here we have the answer in grams, but we have to answer it in kilograms, so it would be 1.007 times 10 to the power of minus 3 kilograms. Generally, when we look at such a question, we get tempted to answer it the crude way. That is, to get the mass of an Avogadro's number of protons, we try to multiply the mass of a single proton with Avogadro's number. Also, because we need the answer in kilograms, we apply the conversion factor that 1 U or 1 AMU is equal to 1.66 times 10 to the power of minus 27 kilograms. So if you put in all these values, it becomes 1.007 times 1.66 times 10 to the power of minus 27 kilograms times Avogadro's number is 6.022 times 10 to the power of 23. And you would try to simplify this and spend a lot of time on this. Even after doing all this, you would get the same answer. But even if you wanted to do this the crude way, we can avoid this simplification process. How? Now, on the latest atomic weight scale that we are currently using, the relative atomic mass, or in other words, atomic weight of C12 atom is by definition taken as 12 exactly. This is by definition. Now, if the relative atomic mass of C12 is 12, then what is the mass of 1 mole of C12? You know how to figure this out. If the relative mass is 12, the mass of 1 mole of that substance is its relative atomic mass or relative mass expressed in grams. So if you take 12 grams of C12 isotope, that means you have 1 mole of C12. And in 1 mole of C12, how many C12 atoms are there? You know the answer. 1 mole of any substance contains an Avogadro's number of particles by definition. So 1 mole of C12 means the mass of an Avogadro's number of C12 atoms, and that is nothing but equal to 12 grams. Now, can I write this as n times mass of one C12 atom? Mass of n C12 atoms is nothing but n times mass of one C12 atom, and that is equal to 12 grams. Then if you take the Avogadro's number to the right hand side, you will have mass of one C12 atom on the left hand side, and on the right hand side you will have 12 over n grams. So this is the mass of C12 atom in grams, and here capital N is Avogadro's number. Again, on the atomic weight scale that is based on C12, that is currently being used, 1 U or 1 AMU is by definition equal to 1/12 of mass of one C12 atom. Now, what is the mass of one C12 atom in grams? This much, right? So let us substitute this value here. So it will be 1 over 12 times 12 over n grams. Cancel these two. So you will have 1 over n grams on the right hand side. So one unified atomic mass unit or atomic mass unit is the reciprocal of Avogadro's number in grams. Actually, this is how we figured out the value of 1U in grams or kilograms. It is the reciprocal of Avogadro's number. So to know the value of U in grams, what do you need to know? The value of Avogadro's number. So we have to measure or figure out the value of Avogadro's number experimentally to know the value of 1U in grams. And that's exactly what we did. We experimentally determined the value of Avogadro's number and found it to be 6.022 times 10 to the power of 23 approximately. So 1U or AMU is equal to 1 over n grams, and this relationship is quite handy. And if you substitute the value of n here, that is 6.022 times 10 to the power of 23, and simplify this fraction, you will get its value to be approximately 1.66 times 10 to the power of minus 24 grams, or 1.66 times 10 to the power of minus 27 kilograms. Actually, this is how we figured out the value of 1U in grams and kilograms, by experimentally measuring the value of Avogadro's number. So coming back to our question, instead of using this value of U in kilograms, we can simply put or replace 1U with 1 over n grams, right? So then it becomes 1.007 times 1U is equal to 1 over n grams. 1 over n grams multiplied with n or n0. These two are one and the same. So then the answer again becomes 1.007 grams. So that is how you can avoid this complicated calculation. Try to remember that 1U is 1 over n grams, where n is Avogadro's number. Now the next question says, what is the molar mass of electrons? Simple. Molar mass of any particle is equal to its relative mass expressed in gram per mole. Now if the mass of an electron is given as 5.48 times 10 to the power of minus 4U, then the relative mass of the electron would be just that number, 5.48 times 10 to the power of minus 4. Then the molar mass would be 5.48 times 10 to the power of minus 4 gram per mole.